Now let us move to the second Newton's law of motion. Newton's second law of motion, the indicator there, when it comes to a description of these principles of Newton's second law of motion, okay? What are the different situations or events that we can cite based on the Newton's second law of motion? There are very important vocabularies that we have to take note, like the word Newton's second law of motions that states that the acceleration of an object is equal to the net force exerting on the objects divided by the object's mass. Means to say that the gravity downward force is already involved due to its object mass. When we talk about how heavy or light the object is. Not only pushing or pulling an object. Push with force exerted. Say for example, a car is moving or it is accelerating, speeding up. By adding mass to the car, how heavy the car is, and the pushing force that you get with less acceleration. So in this case, since we're talking about acceleration, how the object speed up, speeding up, accelerate, okay? There is a positive acceleration. Acceleration may contain in a matter of time and of course direction. How to get those equations? Acceleration is equals to force divided by mass. Means to say that acceleration is directly proportional to the force and inversely proportional to the mass of an object. Okay? So remember guys that the unit of acceleration is mass per square seconds. Okay? While the force we can use Newton. Then the mass we can use kilogram. So to continue, there is what we call circular motion. Okay? How circular motions happen? Any motion in which an object is moving along curved path. Okay? So if there is a turning point of an object, especially when you drive your car, your bicycle, your motorcycle, there is always a circular motion. Not only the tires and wheels, but the way how you manage your driving, or you are in a circular motion. For example, if there is a turning, place or area where your vehicle can pass through circular motion. When it comes to driving, your capacity, your capability, even if you are running or walking along the way. So, if any motion in which an object is moving along a curved path, so we still have to consider about its effect of acceleration. Considering with the presence of mass and of course the presence of gravity and the force. Next one is what we call centripetal force. What do you mean by centripetal force? So centripetal force, guys, it is a circular motion, a force that acts perpendicular to the direction of motion toward the center of the curve. So say for example, you have a string, then you tie a stone at the end of the string and then you hold it. Okay, so you hold that one, that's what we call centripetal, between the string and the stone. So it depends if you're going to release that one, but still, we can do it through circular motion again and then we can release. And how long could it be? It might also involve with projectile motion. So the perpendicular motions according to its direction of motion might also refer, okay, toward the center of the curve, okay, or even passing in that point of reference, the center of reference. Right? Next one. So what is Newton's second law of motion? Let's explore further so that you will understand what does that mean. How the forces change under the second Newton's law of motion. Forces can change an object's motion by changing its speed, its direction, or both its speed and its direction. Okay? So that's the way how you change the motion, by changing the speed and the direction, or both. Next one. Forces change its motion according to velocity. So velocity, that is, okay, a record of the total speed in a certain direction according to various changes, or how those things changed. Right? Next one. Only unbalanced forces change an object's velocity. Only unbalanced forces change an object's velocity. So the more force, the more acceleration. Okay? The more the force exerted, the more the object's accelerated. Keeps speeding up. For example, you apply higher accelerator when you drive your car, or even you apply, okay, higher accelerator when you drive your motorcycle. Of course, you expect that your acceleration keeps getting higher or accelerating when you speed up. That is how the second Newton's law of motion emphasizes, okay, continuous moving. Okay? Once you apply how fast or how slow it is. So applied force, okay, friction applied force when you are at constant speed. So you have your maintaining speed when you drive your motorcycle. Okay? You always maintain around in between 30 to 40 or always 40 km per hour. Holding your accelerator in order to have a constant speed of your motorcycle, or even when you drive your car. Then the applied force keep moving. Okay? When a friction applied force is greater than the friction, accelerating or acceleration point is present. Another point that you have to remember, when applied force is less, so the friction applied force is lesser than, that's what we call deceleration or slowing down until stop. Okay? Deceleration means to say slowing down the motion. Acceleration means to say speeding up your motion. Constant speed means to say you maintain your motion. Okay? Until you speed up or the time you slow down. So those are the changes when unbalanced forces act on an object at rest. The object begins moving in the direction of the net force. If the net force acting on a moving object is in the direction that the object is moving, the object will speed up as well. Okay? So if the direction of the net force of an object to the direction of the object moves, the object will also slow down. As I've said, in a real life situation, sometimes we walk fast, we run fast, but there is time that we have to maintain our speed, according to our comfort of our body. Either we're driving our motorcycle, bicycle, or even our car. There is always an adjustment when it comes to our force that we're going to apply in order to accelerate, in order to have our maintaining speed or constant speed, or when is the time that you need to slow down until stop. Okay? This involves with what we call the direction of the net force of an object is opposite to its direction, and the object moves, or either the object will slow down. So when unbalanced forces act on a ball at rest, it moves in the direction of the net force. So if you remember last time, okay, go back to the first Newton's law of motion between balanced and unbalanced forces. Okay? Under the first Newton's law of motion or net force. So, balanced forces, that means that when the force exerted by hand between the ball that you're holding, so there is always force due to gravity. Once you release the ball, you can no longer hold it. That ball will fall down into the ground. Okay? Due to its gravity. Downward force. In an unbalanced forces, okay? In an unbalanced forces, there is no control at all. Okay? So once the object drops on the ground due to force or it's because of the gravity. So there is no control at all with your hand. Okay? Unlike the balanced forces that you might able to control to not let the ball, okay, to release, and it remains at rest in your hand. Okay? So another point that you have to remember is unbalanced forces can change an object's velocity by changing the object's direction. So, for example, you're moving wheel and barrow, or you're pushing a cart. Okay? So it depends also with your acceleration, your capacity of pushing that cart. Either that cart may contain heavy object. Okay? Even though it's convenient to push that cart, it's because there is tires. Okay? However, it also depends on the load capacity, and of course your force that you're going to exert when you pull or push that car from time to time. So it depends also with the load of an object on your car. So acceleration point. When can we accelerate? When you push our car. Okay? So when we push our car, it will accelerate if we walk fast, or maybe we run fast with our while pushing our car. But if you want to have a constant speed, so we can do the same thing. It depends on your not too fast, not very slow, but you are on the maintaining speed when you push or when you pull your cart, okay, from time to time. And then the acceleration point also, it depends on the tires that we use. which is present on a car. Another name for a change in velocity over time is what we call acceleration. Okay, what is the other name for a change in velocity? That's what we call acceleration. Remember that unbalanced forces make an object accelerate by changing its speed in its direction or both. So according to the Newton's second law of motion, okay, the acceleration of an object is equal to the net force acting on the object divided by the object's mass. So therefore, Newton's second law of motion, when you are going to get acceleration, okay, with the standard unit of meter per squared seconds, m per s 2s, squared seconds, then that's directly proportional to the net force with inversely proportional with the mass. So therefore, A is equals to F divided by M. So again, A is, or acceleration, is equals to the force, okay, net force divided by M, or mass. So A is equals to F divided by M. So that is a standard equation of acceleration. So if you are going to consider this kind of formula, in this equation, there is what we call, okay, the mass of an object is 0.5 kilogram. Okay? The force may contain 10 Newton or 10 kilogram. So you need to find out acceleration with this one. So we use the formula again. A for acceleration equals to F for net force divided by M for a mass. So substitute the value for F and M into formula. So we need to get this one. A is equals to 10 Newton divided by 0.5 kilogram. And then we proceed to, that will be 20 meter per squared seconds. Okay? Once we divide 10 Newton divided by 0.5 kilogram. So therefore, the acceleration of the ball is 20 meter per squared seconds. How? Again, use the equation of acceleration divided by net force. Okay? Acceleration is equals to net force divided by the mass of a ball. Alright? Then, therefore, our acceleration of the ball is 20 meter per squared seconds. So to continue, the direction of acceleration is the same as the direction of the net force. Okay? So again, guys, what is the formula? Always remember the formula of acceleration. Acceleration is equals to F for the force or net force divided by mass. What is the unit of acceleration? Meter per squared seconds. What is the unit of a force? That's always been Newton. What is the unit of mass? That's always been kilogram. Okay? So therefore, acceleration is expressed in meter per squared seconds. M per S2. Mass is always expressed in kilogram or